This is question 2A from the test 3 from 2019. In this question here, you're told that 0.2964 grams of an unknown metal is deposited upon a passage of current 0.5 amps. From 0.5 amps, that's equal to coulombs per second. Keep in mind our units. And that's going for 30 minutes, minutes through a solution containing the 2+ ion. You also want to, or in the end, you want to identify the metal by calculating the molecular weight. So what else we know from this is that, well, first of all, it's saying we're depositing a particular metal. So what's occurring is we are making M, and we know that in the solution we have M2+ ions. So to balance this equation right here, 2 electrons, we know that M2+ is being reduced. So this is a reduction equation. So first things first now, if we want to find molecular weight, that is equal to mass over moles. We're given our mass, but we don't have our moles of M. But we do have a balanced equation up here. So if I want to find moles of M, I can either find moles of one of these over here. So I can find moles of electrons potentially from my current and time, so finding the charge. The other thing here you want to look at is that our time is in minutes. We always want time to be in seconds when we're doing these types of questions. So make sure you do your conversion. So that's 1800 seconds. I think we're set up to start doing this question. Now, our equation that we normally use, Q equals current times time. We also know that it's equal to the moles of electrons times F, Faraday constant. So we can solve for moles of electrons without trying to find our charge. We have everything else here. So that means our moles, and I'll just put a little E down here, moles of electrons is going to be equal to IT over F. So if you sub everything into here, we know I is 0.5 coulombs per second. We know our time in seconds. Make sure you've gotten all this. And Faraday's, which is 96485 coulombs per mole of electrons. That's where you're getting that unit. And if everything has been punched in correctly here, you should have a value of 0.009328 moles of electrons. Now we need moles of metals, and we know our stoichiometric relationship up here. So if we want to find then moles of metal, we're going to take what we just had for electrons, do our conversion factor. So it was 2 moles of electrons for every 1 mole of M. So we will have then a value of 0.004664 moles of M. And using this number for your moles, that number for your mass, you should be able to get your molecular weight out of this, which is 63.55 grams per mole, which corresponds to copper.